Hello there guys, welcome back to another epic inexorable maths video. In this video we're integrating arctan x, the inverse function of tan, and we're going to use integration by parts, believe it or not. So if you're not familiar with this, if you're thinking to yourself, why on earth are you using integration by parts for this? Because integration by parts requires a u and a dv dx, and we only have one of them. There's just one function here. There's no product. How are we going to do this? If you're thinking that, then go and check out my previous video integrating the natural log of x, because we're going to do something pretty similar. So we're going to use the same strategy, and we are going to let u equal the function, which is just arctan x. Now you might say, what should we let dv dx be then? Because there's nothing else there. Well, dv dx can just be the number 1, because we can pretend, or not necessarily pretend, but just imagine that there is a 1 timesing by the arctan x. So dv dx will just be the number 1. Now, if you don't remember what arctan differentiates to, that's normally okay, because a lot of the time the derivative of arctan is in a formula booklet, or they don't expect you to remember it. If they do expect you to remember it for whatever exam you're doing or whatever, then you need to remember it. But don't stress. Arctan differentiates to 1 over x squared plus 1. I've also got a video on this. I'll leave the link in the description. Okay, so v, which is the integral of just the number 1, is just going to be x. Okay, so these are our 4 things. Now we're ready to just go straight into the integration by parts formula, which is just that yellow box there. So we know that the integral of arctan x with respect to x is going to be uv. So u is arctan x, v is x. So I'm going to write that as x arctan x. And then we're going to take away the integral of v times du dx, which I'm going to write as x over x squared plus 1 dx. Now, this integral is really not too bad at all. That integral is just going to involve a natural log. So let's go through it now, but I'm just going to rewrite this line here. So we have, again, the integral of arctan x. This is equal to x times arctan x. My handwriting is becoming progressively worse as we go lower down the board. And what we're going to do here, guys, is we are going to use the natural log. And the reason why this is a natural log situation, because some people get confused, when is it a natural log? When is it not a natural log? Why is there a natural log there at all? We have a bit of a pattern going on. Whenever you see a natural log when you're integrating, this is kind of how it works. Do you see, we have a fraction. The numerator of the fraction, which is x, is a multiple of the derivative of the denominator. Because if you differentiate only the denominator of the fraction, x squared plus 1, you get 2x. And 2x is just 2 times the numerator. Whenever you have that situation where the numerator is a numerical multiple of the denominator, you're going to be looking at some number times the natural log of the denominator. So it's going to be equal to some number that I don't know, so I'll leave a little space for now, multiplied by the natural log of whatever the denominator is. In this case, it's x squared plus 1. And I know already that I'm going to have a plus c here, so I'll put the plus c now so that I don't forget. But what number goes here? Well, let's think about it. If we differentiate the natural log of x squared plus 1, we will get 2x over x squared plus 1. We don't want that, we just want 1x. So really, we're only looking at half of this. That's all we want. So we should put a half in front. And you don't need the modulus or the absolute values on the natural log, even though when you're integrating you typically do, simply because x squared plus 1 is always positive. So you don't need to worry about when it's negative and making it positive. You can just use normal brackets. So this is the entire answer. The integral of arctan x is x arctan x minus a half the natural log of x squared plus 1 plus c. Hopefully that makes sense, guys. Thank you so much for watching, as always. Highly appreciate it, and I'll see you in the next video. Cheers.